Okay, so I'm live here with 52 weeks of Swift, episode 7 closures. Going to talk about how they work with Swift. And let's go ahead and get started. I'm going to share my screen. Let's go ahead and get this thing going here. So to start with, in Swift here, we can see that closures are self-contained blocks of functionality that can be passed around. And so in the world of distributed computing, which is really the world we live in with cloud computing, it's really a great strategy to have some kind of closure in your code base, because really you can just pass a piece of code around. It's got everything it needs to do its work, and then it does its work, and then it returns back a result, or just goes away because it's done working. So here we can see here that you can see that there's global and nested functions. So typically that's how the closure works, right? Is that you have a function with outer scope and it has an inner function. It retains that state, and then it goes through and does its work. So global functions are closures that have a name and don't capture any values. Nested functions are closures that have a name and can capture values from the enclosing function. Closure expressions are unnamed closures written in lightweight syntax. So there's a few different flavors here. So Swift's closure expression has clean, clear style with optimizations that encourage brief, clutter-free syntax in common scenarios. And so this means that you can do inferred parameter return type, implicit returns from single expression closures, shorthand argument names, trailing closure syntax. The closure expressions here, these are nested functions, are convenient ways of naming things around. So let's go ahead and play around with some of the stuff here. We see here the sorted method. The Swift standard library provides a method called sorted by, which sorts an array of values of known type. And so the closure expression below uses the sorted by. So let's go ahead and use this. Let's play around with how this works. I'm going to bring this over and pass this in. We've got this immutable variable again here, and this one is let names here. And then if we want to use this, I guess what we can do is we can actually build out, it says one way to provide the sorting closure is to write a normal function of the correct type and then to pass it in as an argument to the sorted by. So this looks kind of interesting here. So let's paste this in. So we have a function that comes in here. This one says backwards. And what it does is it takes a couple strings and returns back a bool that returns in itself, let's see here, something called the first string S1 is greater than the second string will return true. So basically it's a conditional statement that is returned here. And so what we do is we have var reverse names. So we have a mutable variable, and it says names.sorted by backwards. I see. So we're basically applying a function we wrote to this sorted, which is pretty interesting here. So if we go through and we look at what this does, it's able to do a backwards sort. So essentially, I guess what we're doing, if I go back here, it says the sorted by method accepts a closure. So basically, this is in a way kind of similar to the way things work with, like, let's say pandas, for example, in Python, where you would have a piece of work, a function, you would have some data frame, you apply it, it does the work. Similarly, Python has a sorted as well, where you can give it a piece of work, a function, and then apply it to maybe a custom sort method. So it's really with a closure in this case, you're able to apply your own custom logic to something, and that's really one of the cool things about closure. So here we go. The closure expression syntax is the following form: parameters and then return type. So the parameter in the closure expression can be in-out parameters, but they can't have a default value. So here we go. This example shows a closure expression of the backwards function from above. So we say reverse names.sorted by, and we can actually build this all together. So let's go ahead and build that in and paste it in and see what we got here. So we have reverse names is equal to names dot sorted by. There we go. And what is the result here? If we go back here, is essentially the same thing. And so in this case, it shows us basically the style here. It says because the body of the closer is so short, it can even be written on a single line, which is kind of neat here. So these are essentially letting us do inline functions, which is pretty cool actually. Python as well has this with lambdas. So this basically illustrates that the overall call to sorted has remained the same, but there's 3 different ways that we did it. But the argument now, as I mentioned, is an inline closure. So you can do an inferring type from context because the sorting closure is passed as an argument to a method. Swift can infer the types of parameters and the type of values it returns. And so in this case, because of the types can be inferred, the parentheses around the name can be omitted. So it's kind of neat. Even shorter way to write this. I like short methods. And so I'm just going to get all this out. And we can just say reverse names is equal to names dot sorted by. And if we go and we return this, does it? Oh, I think it's missing the. I took too much out. We need. What do we need here? We can. I think we're missing some variables. What is this missing? Let's go ahead and do this. Reverse names sorted. Let's go back again. Take everything here. I don't know what values I'm missing, but let's just paste this in at the bottom and not care about it. There we go. There's a variable missing that I didn't define that we're good now. So I guess in a nutshell, you can write a very concise closure by getting rid of return types, and you can do an inline function, which is pretty neat. So implicit returns from single expression closures here. So single expression closures can implicitly return the type as well by omitting the return. So here we go. Here's another way to do this. So we say implicit return. There we go. Reverse names are sorted by. So that's pretty neat. I definitely will probably play around with this later. And then we have shorthand argument names. Swift automatically provides shorthand arguments to inline closures, which can be used to refer to values of the closure's arguments, $0, $1, $2. So the in keyword can also be omitted because the closure expression is made up entirely of its body. So yeah, that's pretty cool. This is a neat little trick here as well. And operator methods, there's an even shorter way to write closure expressions above, and that is basically by using the greater than operator that has 2 parameters of type string and returns a value of bool. This matches the method type. Therefore, you can just pass a greater than operator and Swift will infer you want to use it to do string-based implementation. Wow, that's pretty cool. So wow, they took this thing and they really brought it down to a very tiny amount of code. So basically, this is a function that essentially an inline function that's just a greater than. I'll have to look back at that again. That's pretty incredible. Okay, so trailing closures, if you need to pass a closure expression to a function as the function's final argument and the closure expression is long, it can be useful to write it as a trailing closure instead. You would write a trailing closure after the function calls parentheses. So here we go. We have a function. The function body goes there. Here's how we call the function without using the trailer closure. And here's how you call it with a trailing closure. I see. So we say func. Looks kind of interesting. So I guess we could take all this up and pass this in. So there's definitely some pretty interesting patterns here that I'm discovering with this. And then it says the string sorting closure from the closure expression syntax can be can be written outside of the sorted by, and then methods parentheses show a trailing closure. So here we go. We'll go through here and we'll do this and reversed names. There we go. And we also can do this a slightly different way because you don't need to write the parentheses after the function when you call it. Okay. It's kind of interesting. So you can also build it that way. Trailing closures are useful when the closure is long. It isn't possible to write it in line. Okay. So here's how to use a map method. So map is pretty common as well. You have a function and you want to map it to, you have something you want to, usually an array, and then you want to map a function across each of the items in an array. Typically, that's how I would use this. So we're going to do something similar. I'm just going to get rid of all this stuff. We go let digit names, let numbers. Here we go. And in this one, I think I just need a trailing bracket. There we go. Perfect. And then next up, what I'm going to do is you can use the numbers array to create an array of string values and pass a closure to the array map method. And so what this one will do is we'll map this out and we'll apply that to, I believe, every item in the array. And we can go ahead and, pass this down below. Just go ahead and do that. There we go. And we can see what the results are of that. It says the map method calls the closure once for each item in the array, as I just brought up. You don't need to specify the type. Okay, so that's pretty neat to know. So you can basically make an array, and then if it has a map method on it of the array, you can actually go through here and apply it. That's nice to know. So here's a function that takes multiple closures. You omit the argument label. For example, this function loads a picture for a photo gallery. Interesting. I think this will probably not work, so I won't run it. When you call this function a load a picture, you provide two closures. That's pretty interesting. And then capturing values, a closure can capture constants and values from the surrounding context in which it's defined. The Swift simplest form of closure can capture values is a nested function written within the body of another function. So here's an example, a function called make incrementer. Interesting. So we've got this make incrementer function. Let's go ahead and run this. This looks pretty fun to play with. Okay. Oh no, I need to give it a func word here, make incrementer. That appeared to work. Great. And then if I bring this over, we can see it says 1, 6, 7. Okay, so it's able to do that. So the return type of make incrementer is integer. This means it returns a function rather than a value because we're saying make incrementer, and then we're building a nested function inside, and then we're returning the inner function. So the outer function has some scope here, which would be this, and then this incrementer goes to running total, reaches up into its parent function, and then increments that. And so I'm assuming we're going to call this. So when considering an isolation, the nested incrementer function might seem unusual. It doesn't have any parameters, and yet it refers to running total. As an optimization, Swift may store a capture and copy. So here's an example of make incrementer in action, right? So now what we can do is we can basically run our closure, and we can say let increment by 10, and then what this will do is it will just keep incrementing. Okay, that's interesting. So increment by 10. So we can basically keep, because it's able to talk to the parent state, we can just call this over and over again. And each time we call it, it'll increment by 10, which is pretty neat, right? And so these kind of patterns, I think, are great for, I think games would be a good example of this, right? You have some kind of game mechanics and you want to kind of build that game mechanics into a closure, and then you queue it up and then you pass that somewhere else. And then this could be some kind of game-based mechanic. So this is a neat little pattern. I'll definitely play around with this later when I get a chance. And so here we go. And we want to make an incrementer by 7. And we can do that by 7. So I think this is probably the cleanest and most explainable way that I would probably use this. Is you just keep calling it and it just increments by that value. So to me, that's pretty clear. Okay, closures are reference types as well. So they're constants, but the closures refer to values that are still able to be mutated. And so this also means that if you assign a closure to 2 different constants, both of those constants refer to the same closure. That's pretty interesting. So if I first do this and I call it again, I see. It's still referring to that same state, which is pretty neat, actually. So basically, we have side effects because we have another function going back and reaching into that same parent's function's value and incrementing it. So again, this would work very well for some kind of a video game type mechanics because you could have something that keeps track of that state. So a closure is said to escape a function when the closure is passed an argument to the function, but it's called after the function returns. So you can declare a function that takes a closure as one of the parameters, but you can write escaping to indicate the closure is allowed to escape. Wow, that's pretty interesting. I would have to study this a little bit to see what this does. This seems pretty exotic, but sounds kind of interesting. And I guess we would go through here and trial this out. Yeah, interesting. So I don't know necessarily when you would want to use something like this, but it's nice to know you've got it. Auto closure. So an auto closure is a closure that automatically is created to wrap an expression that's being passed to an argument to a function. It's common to call functions that take auto closures, but it's not common to implement that. I see. So an auto closure lets you delay evaluation because the code isn't run until you call the closure. Delaying evaluation is useful for code that has side effects or is computationally expensive. So I have definitely used this pattern before. And yeah, if you were going to do like k-means clustering or something, and you had a whole bunch of k-means clustering jobs running, you would queue them all up in like kind of a partial pattern. And then when they're ready to be invoked, you would all invoke them at some interval. So yeah, I've definitely used that pattern before. And that's kind of a cool pattern. And this serve function is listed above, takes an explicit closure that returns the customer's name. So yeah, pretty interesting. So that I didn't have a ton of time to spend on the closures today, but that's good enough for me. I got a good feel for what's happening here. So just, I guess in a nutshell, what I would recommend if you're interested in playing around with Swift closures, I think the incrementer one is probably the one to me that's the most intuitive and probably a good place to play around with. And so I would maybe focus on building something with that incrementer function, get that thing started. And then some of the more exotic ones, I mean, it's nice to know because it's a language reference that those are available. I don't know if I would go out of my way to write very exotic, methods with some of these things, but it's nice to know you can do complicated things with Swift. One thing to be aware of with inline functions, though, is it can be very easy to write code that's complex to debug. That's why I don't like in Python the inline functions. I typically just write, if I'm going to write a closure, I write it inside of the function, and it's very clear what it is that I'm doing. So I like the kind of traditional closure where you have a outer function, inner function. You can look at it visually and see what's going on. All right, so that's it for me for this week with the Swift. Next week, I'm going to go over enumeration. which is a common type for group related values. And I will see you next week.